CircuitPython
For the CircuitPython Parsec today, I wanted to shift gears and talk about using hierarchies of groups in displayio. So what does that mean? Well, if you have an object in displayio on a screen, such as these shapes here, circles, triangles, squares, and you want to adjust their position, you can simply adjust the position of the object, so circle.x, circle.y. However, sometimes you want to move collections of objects around together. So I'm going to keep these two circles here, essentially inseparable. So you can see here there we go. If I move one circle, I'm moving the other circle. If I move one triangle, I'm moving the other triangle. If I move one square, I'm moving the other square. So those are inside of a conceptual group. I'm not drawing an object for it, but you can imagine they're in an invisible box. And then I've taken those three groups that each contain two objects and put them inside of a bigger group that I'm just calling screen. So this gives me the effect of sliding a screen around, maybe scrolling around if you think of this as something like an image editor or a Palm Pilot or that sort of thing, something on your phone. So the ability to move objects individually in groups and in groups of groups is really helpful for a lot of user interface design. So the way that we do this inside of CircuitPython, what I have here is let me flip it upside down, is that same feather, RP2350. I repurposed that from the other demo. And it's plugged into this 3.5-inch 480 by 320 TFT Featherwing V2 with capacitive touch. And that's how I'm able to input XY positions as I touch the screen. In the CircuitPython code here, I'm importing some libraries that make all of this work, particularly displayio. I'm using vector.io for the fast draw of those shapes. And then I have the driver for the display and the capacitive touch on there. This display works over SPI, so we set that up for the appropriate pins on the feather. And it also uses I2C for the capacitive touch. Then we're setting up a palette of colors so that I have the red, the green, and the blue. And then here comes the hierarchies. So the sort of highest level of this you can think of is this scene displayio group. So that group contains a group of groups. So we have scene displayio group, and that is a root group. Then I create two circles inside of their own group. So I create the circle group, that's a displayio group in some particular position. And then I append to that one vector.io circle and a second vector.io circle. And those are just given their own different positions, 30 units away from each other, or 60, I should say, units away from each other. Do the same for the triangle. So that's another group that contains two objects. And then the third group here is this square group, which contains two squares. Then you can see right here, this is the key to getting things to move together. I append to that top level scene group, the circle group, the triangle group, and the square group. So that means we inherit movement or any kind of transforms. So as I change the XY position of scene, that then passes that along to circle group, triangle group, and square group. As I adjust the XY of triangle group, it passes that transform along to triangle 1 and triangle 2, and so on. And then the nuances of this are things like adjusting our hit regions so that we have essentially a bounding box around things that we know we've touched when we press the touch screen. So that position right there knows that I have shifted that triangle group or that square group so that those will pick up and move. Doing a little bit of smoothing of the touch here to avoid jitter. Still get a little bit, but not bad. And then in the main group, we're just checking for touch points to align with either the scene group or those individual groups, and then adding or subtracting X and Y coordinates from those. And so really it's all in the setup. Moving them is easy. So that's the easiest way to move groups of groups inside of CircuitPython in displayio. And that is your CircuitPython Parsec.